Okay, hello, Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Muhammad Farid bin Nazree. I'm from BNE. My matrix card number is CN190263. My supervisor is TS Dr. Lam Song Yin. Okay, today I want to present my project, which is development of prototype data acquisition for photovoltaic system. Okay, next slide is the introduction. Okay, okay, the introduction. Okay, this is a DAQ system. The demand of, as we know, the demand of power production for by renewable energy to the electricity supply constantly increase, particularly in photovoltaic system, which is a solar power. In fact, to a large extent, solar energy can curb the energy crisis and global warming. Nevertheless, power generated from the solar energy exhibit the fundamental different characteristic than the conventional energy. While the power production from conventional source can easily be matched to the given electricity demand, the availability of the solar energy is primarily determined by the prevailing weather condition. Therefore, they are highly variable. Such high variability of solar energy poses a significant challenge for integrating the renewable energy into existing power system, which they are require of balancing supply and demand. Okay. We're gonna talk about the problem statement. Okay, the problem statement in PV system. Okay, there are three parts. Okay, first part is environmental condition, sustainable energy, and the PV data accuracy. Okay, the solar power energy technology is a convincing approach to provide more sustainable energy and to relieving the global environment crisis. Okay, however, the availability of the solar energy is largely determined by the prevailing weather condition and is therefore highly variable. The detailed information on the expected power production require accurate solar power forecasting for an efficient integration of power system. The correctness of PV power forecast for grid integration is crucial for grid integration, where is it directly connected with their accuracy. Hence, the need of precisely forecast PV data will be the key motivation of this purpose of work. Such solar data can provide the effective forecasting and the management of solar resource on the power grid, especially in Malaysia. For this respect, it's worthwhile to develop a data acquisition monitoring system for solar power pertaining to the peculiarities of climate and in this region. In fact, the sufficient data collection obtained from the data acquisition should help explore the characteristic of PV forecasting and model in this region. Okay, next is the objective. Okay, the main goal of this study is to develop the prototype of data acquisition system hardware for photovoltaic system monitor. To be more specific, first we develop a prototype of data acquisition system hardware for photovoltaic system monitoring and reporting. Second, we develop a program software for data acquisition suite which can store the monitor sorry, which can store the monitor parameter from PV system. Third, to integrate software and hardware for the develop data acquisition and validate the function performance of the prototype system. Is the project scope. Okay, the scope of this project. First, this project is slowly implemented based on the prototype of the AQ station for photovoltaic system. There requires several important parameters from the PV panels, such as the temperature, voltage, and current. The graphic user interface GUI for the DAQ station, which associate and incorporate algorithm with associate and incorporate algorithm with Raspberry Pi. A photovoltaic data acquisition system will be developed and record every minute of the PV solar power from the solar panel. The DAQ that has been obtained will refresh for every minute to gather new data. So the the data will be measured every minute, so it will be new and the reading will be accurate as possible. Okay, the project flow. Okay, in this project flow, okay, we divide it in three objectives. Okay, in the first objective is we show the general workflow purpose of this work, mainly used based on the extensive analysis of the circuit, designing and decoding process. The follow of the work already addressed in the objective one, which we start which we start processing all the program which we need to work with all the component that we will use. In this process, we can try the error by the using stimulation and needed application, finding the right component which we can integrate to integrate the directly to the software that has been developed, which is mostly we focus on designing the prototype, the circuit, and how we gonna implement it in our project. Okay, the second stage which the work will be focused on developing the program and creating the GUI, which that can perform the as expected. The GUI consists on the interface for the data monitoring with alongside proper hardware that measure the data. All the data that has been collected will go to the data logger. All the data will be collected from the solar panel. We'll use in the prototype. The hardware will also be programmed to work on how many times it's going to be measured alongside the all component. The validation for this model will be carried out through the solar evaluation. This such work will complete the second objective proposed in this proposal. Okay, the final stage of this uh, this project flow. This is the objective 3, validate data and performance testing. Okay, this final stage we will more focusing on the evaluation and the validation of the physical model developed from the second objective. The data acquisition DAQ will be developed to obtain an actual photovoltaic parameter. Then the validation physical model will be compared to the measurement data with respect to the efficiency of the physical model. Okay, this is the AQ system overview, which is a block diagram for the AQ system. Okay, in this segment, it shows how the prototype works. The system start from the monitoring, where there are GUI that helps to monitor the GUI. Help to monitor. The GUI will be connected to the internet, and there will be the data storage in the cloud. All the PV data that has been collected will be go to the data logger, which is it's collect directly and has been stored for the data analysis if needed. After the data logger collects the data, it will send the data by using the connection that's connected to the internet, and the data will be accessed by the GUI. Okay, the four block diagram sensor. Okay, the block diagram sensor, this is show where all the sensor is going to be located. The sensor is for collecting all the data needed, which is the current sensor, voltage sensor, and temperature sensor. Every type of sensor will be recorded, and we need to measure all the data from the GUI, which the user can access from the remote location. Okay, the block diagram for the AQ station. Okay, in this segment, this system start with an input sensor, which is a temperature and light sensor. They are followed by the several ADC field output, which is a LED, LCD display, data logger, and GUI interface. Okay, this is a schematic diagram for the AQ station. The block diagram and schematic for this generally method used in the integration of the AQ system. By using the temperature sensor DHT11, that's the type of model sensor we're going to use, is as the input for the system and followed by the Arduino SD card for the communicating between the microcontroller and the SD card use SPI. The function of the module are formatting and preparing the memory card file naming as well the opening and closing file. Next, using the Arduino as the controller is used to link all the component, get the digital data from the ADC process and store them in the memory card. It's also distribute power to all the sensor. Lastly, we monitor and process the data using the personal computer. Okay, and then for the preliminary results. Okay, these are the several tries and error that we currently using the Arduino to run the program just to make sure the circuit design is correct. There are also several components that we just try to make sure that we know the Arduino works, and for just the purpose of testing, we try for we try some components. Okay. Uh, the second picture, as we see here, is a hardware installation using the current sensor. This shows if the current sensor we using is suitable for our purpose. Okay, this is a Gantt chart. Okay, this Gantt chart it consists for 14 weeks, which is we develop our we develop our title project and consult with our supervisor, and then the project title and preparation for project, research the literature review, determine the methodology of the project, also discuss the component hardware to use. Uh, there are several testing that we use. We also send the report checking by the supervisor and preparing the report and submission the proposal report. Okay, this is the list of all the reference that I use for this project. Okay, that's all. Thank you for me. Assalamualaikum and have a good day.